Okay, there are two ways of structuring your paper. First one is inductive and second one is deductive. By the way, I told it to 학생회장, but please share this link to all students from next year. You should write something like this one. Okay. First, okay, either inductive or deductive. Inductive is your paper should follow this suggested structure and answer the question in the bullet. Do not write the question and answer them bullet by bullet. You should construct a sentence that incorporates the answer in a natural manner. Okay. So basically, this is structure, and in your introduction, for example, you have to answer those kind of questions. But what I mean is, you should not answer write down question and put your answer. Don't write something like that, right? It is just a guideline, and based on this question, you have to write your own sentence, like self-content. It is not asking question and answering the question. Okay. So your paper can start with the first 5 sentences. What I mean by first five sentences is basically first paragraph of your paper, which is very important part. If you don't write your first paragraph well, people don't read it. It has to hook up the readers. Okay? It composes of 5 sentences, optionally 6 sentences. First sentence is like an example. Second sentence is discussion of topic. So for example, why your research question is important. You should say, my research question is very important, blah, blah, blah. Third sentence is about consensus about existing literature, how existing literature discuss credit risk, for example, if you write a paper about credit risk. Fourth sentence is example of existing literature. Write one important consensus and cite reference. Fifth sentence is limitation of existing literature. For example, it does not investigate well the impact of credit risk on stock prices, something like that. Final sentence is like this paper investigates how credit risk affects stock return. Okay. Again, first sentence, if you write down only these 6, first sentence is why your research question is important. What are the existing literature about this? What existing literature says? What is the problem of existing literature? So how I can solve this existing literature, problems in the existing literature, okay? That's the very first paragraph, okay? It is 1 sentence, so it is 6 sentences. It shouldn't be that long, okay? And next, next introduction is just the detailed discussion of the first 5 sentences. For example, explain briefly the concept of your paper. Your paper, you use some concept, right? What is real estate, for example? Okay. What is your research question and subject? Then basically, what do you want to answer in your paper, and why is your research question important, and is there any research similar to yours, and what are the limitations of similar research, and what is the additional contribution of your paper to the previous literature research, something like that. Okay, and then because in induction, next you go into the data analysis. In your data analysis, maybe you can select the case or data. Why is your case relevant to your research question, or why is your case important to those academia in practice? Okay. Again, it can be both quantitative or qualitative. It doesn't matter. Okay? Even if you choose qualitative, or like a case study or media article, you still explain why is your case important. Next is data collection. You have to collect the data, of course, and then this section should be very detailed, such that what data did you collect, how did you collect the data. For example, quantitative data, it is maybe from standard database, or maybe you did a survey. If you use qualitative data, you collect the data through interview or archival analysis or media search, something like that. So basically, you have to explain how you collect the data, what is your data about, something like that. Point is that other people should be able to replicate your research by following your data collection procedure. Okay? You know, all scientific papers should be reproducible, replicable. Okay? If other paper follows your methodology and data collection, they should exactly reach the same conclusion. Next, you collect data and you have to analyze the data, write down history, background, other information about your case in appendix maybe. Build at least 2 concepts, constituent concepts from your data. There are at least 2 concepts, X and Y, in your proposition, the more X, the more Y. You know, our paper is about causality, right? If X happens, if Y happens, right? So it means that you need at least 2 concepts, X and Y, okay? And then you need variation in X and variation in Y. So that if X varies and how Y varies. In one sense, that is like a thermo X, thermo Y. So it is. So from your data analysis, maybe you can reach this kind of conclusion. Again, in order to reach this kind of conclusion, you have to define what is X and what is X, and a change of X is change of Y. Okay, match change of X, change of Y. Okay, and then how they vary collected. This will be used to formally suggest your proposition at the next section. So basically, from your data analysis, you find your empirical finding looks like this, and then from your empirical finding, maybe you can discuss more. Okay, so basically, you are building a theory. So from data, you reach, so you have to discuss again what is your logic from data to this proposition. Okay, this proposition is from your data analysis, so it shouldn't be that hard. And then derive a proposition from your data analysis, which is the same thing. The proposition should be look like the more X, the more Y, right? Like the taller man is, the more popular he is. If it is your data finding, basically you need two concepts. What is man? Okay? What you have to define a man, and you have to define what is popularity. Right? Define man and define popularity, and make very like. Okay, no. This first concept is actually height of the man, right? Height of the man, and second one is popularity of man. And then you have to define height. When you say height, it is very easy, right? Like, for example, it is 176 for me, and then something like this, centimeter, something like this. And then the more popularity, you have to define popularity. You have to ask like girls whether do you like men over 180. Do you hate guys under 170, something like that. Anyway, you have to define popularity, and then basically how are propositional so then there is two concepts, height of the man and popularity of man. Then your data analysis, you have to vary. There should be two cases, small man and tall man. And popularity of small man and popularity of tall man. Okay, then you can reach the conclusion maybe not that. Okay. And then there is your empirical finding. So based on your empirical finding, maybe in the next question, how are your proposals relevant to your research question? So your empirical finding is directly related to your research question. You start from your research question, and then it is your finding. Okay. So basically, your finding should be answer to your research question. Right? And then maybe you are the only one. Maybe you are not the only one who found this thing, right? So maybe in the existing literature or other scholars may have already done similar research. Then you have to find them, and then you have to relate your result with the discussion in the previous literature. How are your proposals relevant to your research question? Find similar propositional theories in the literature and discuss, and compare your proposition with those in the literature. Maybe in other literature, they find, maybe some people find that height of the man is not related to popularity. Maybe some people find that. Then you can just say, oh, maybe it is a German case. But maybe in Korea, height of the man is very important for popularity, something like that. But maybe in German research, maybe it is different. Maybe for German girls, they don't care people's height. Maybe not. Okay? But I think in Germany, right, height is important for the popularity. Yeah, in global phenomenon. Maybe in Korea more important. Okay. How do you know that? Yeah, I think it is very important in Korea. Yeah. Korean males. And then unfolding the literature, because it is inductive, so you're start from the phenomenon. So you have to generalize. Now you have to generalize your finding. How does existing literature help you to generalize your proposition? Maybe Korean girls like tall men because it is for DNA more. I don't know. It is for genealogy or evolution perspective, or something like that. And what paper have a similar or different proposition to yours? And what papers drive a similar or different conclusion to yours? What are your additional contribution to your paper? Of your paper in detail, which paper can highlight your contribution. Right? And then conclusion, state what you have learned, what we have learned, and managerial and policy implication and limitation of your research. Any question? So it is starting from phenomenon. Okay, research question, go directly into the data, find something, and generalize your finding. Okay, basically it is from data you have to find something, and you generalize your findings through theory building in some sense. Basically, so you are building a theory in some sense. Second one is, this is the first approach, and second approach is deductive. It means it starts from the theory. Okay, it's title, and then the first part is exactly the same. Your paper should start with the first 5 sentences of your paper, which is exactly the same. And then introduction is almost similar. Explain briefly the concept of your paper. What is your research question or subject? What is your research question important? Is there any research similar to yours? What is the additional contribution of your paper to previous research? And then next, literature review. It is similar. And then literature review, next one is a theory. Okay? There might be a theory relevant to your research question. Okay? So you pick one theory that you think most relevant to your research question. What is your theory about your research question? And find the similar theories in the research because compare your theory with those in the literature. Okay? So basically, you, based on your unique research question, I mean, because usually research question should be unique. Otherwise, if someone already answered your research question, there is no point of writing down the paper, right? So research question should be unique, and existing theory may not fit exactly to your research question. Okay? But there must be similar theories, then you have to modify that logic. So basically, you are modifying the existing theory and fit to the research question. Okay, this is what I'm saying. Okay, so from theory, research question, you found or you basically modified the existing theory to fit your research question. And from theory, there should be hypothesis. Okay, hypothesis such that. So there should be logic from theory to hypothesis, and then you have to derive hypothesis from theory. Again, the hypothesis should be look like the more X, the more Y. The taller man is, the more popular he is. So in this case, maybe your research question is it true that tall men are more popular than small men, something like that? And then existing theory, maybe tall man is maybe more genetically evolutionary perspective in the ancient times. So existing theory, something like that, in the ancient times, tall man has advantage in hunting the animal, something like that. And so that is ingrained maybe in DNA or something like that. So from that, maybe we can derive a hypothesis that the taller a man is, the more popular he is, right? So from that ancient, evolutionary perspective, you have a theory and you derive a hypothesis. And then next, of course, you have to test your results, right? And the empirical test is, again, operationalize hypothesis for testing. What I mean by operationalization, again, you have to define what I mean by a man is tall or small, and what I mean by a man is popular or not popular. Okay, you have to define and measure and test. Okay, and data source and gathering. What data did you collect? What are your data relevant, important to your research question? How did you collect the data? And then it can be either quantitative or qualitative. It doesn't matter. And analysis. Again, analysis is very similar. You vary X and you vary Y. You make variation in height of the man, and you generate variation in the popularity of man. Match it. And then you can test the hypothesis, you can find. And the conclusion is similar. State what we have learned and manage your participation and limitation of your research. Okay? Reference is very important. And then appendix describe your case maybe in detail. Attach your resume. Okay? Please attach your resume. 자기소개서. Okay? And then citation guideline. It is basically APA format. Okay? Please use APA format for your reference. See the following example like this. Okay, this is one of my paper, and the other part of your paper should follow the guideline, AMJ guideline. And if you cite a paper in the body of text, this should be specified in the reference list at the end of the paper. If one article is in the reference list, it should be mentioned at least once in the main body. In your 학술지의 paper, you didn't follow this one. And there is a sample or photo guideline. The sample is not exactly matched to this one, but I think you can modify this. Okay, any question about writing term paper? No, no, right? Okay, I think you have about 1 week, so do your best. Yeah, let's go to today's topic. Today we will discuss a real option. And then this is spreadsheet, real option note. So this is developed by Martin Hawk and Garud Iyengar. Okay, they are the professors in the Coursera course of Financial Engineering Risk Management, and I downloaded this paper from their Coursera lecture. Okay, let's read this one together and try to solve the problem described here. Okay, a brief introduction to the real option and the simply called gold mine. So it is a problem about gold mine. Okay. The term real option, okay, we will discuss today about real option, and the term real options is often used to describe the investment situation involving non-financial, real asset together with some degree of optionality. But I think everything in our life has some degree of optionality. So it means every problem in our life is also kind of real option problem. I think it is a very general statement. So in some sense, everything is about real option. Every problem is a real option problem. For example, an industrialist who owns a factory with excess capacity has an option to increase production that he may exercise at any time. This option might be of particular value when demand for the factory's output increases. The owner of an oil field has an option to drill for oil that he may exercise at any time. In fact, he can drill for oil in each time period. He actually holds the entire series of options. So it is option because you have oil field, you have option to drill or not. Okay? Just imagine it. When you want to drill for oil, you know there is oil underground and you have to decide where to drill oil or not. When will you drill and when you will not drill? What would be your decision criteria? Yeah, when price of oil is high, okay, oil price is high, then I'll drill and sell the oil. When price of oil is very low, then you don't bother to drill. Maybe you will lose money. Let me sure that there is oil. Okay, we know there is oil. And we know how much does it cost to drill for oil. So you have to define benefit and cost of drilling oil. And then, of course, there is a volatility in the oil price, and that will determine our value of drilling option. What do you mean by liquid?
Liquid, financially liquid.
Yeah.
We don't have a lot of cash because we have to pay for drilling. Maybe we have other costs incurring, so we cannot really.
That's good. That's a good point. So let's assume that there is no financial constraint. Okay, when we want to drill, of course we need money for drilling, and let's assume that we can finance it from bank very easily. So on the other hand, if he only holds a lease on the oil field that expires on specific date, then he holds oil on a finite number of drilling options. So if I lease an oil field for the next 10 years, if I can drill oil once per week, once per year, then it means I have 10 options for drilling. Okay? Each option per each year. For a final example, consider a company that is considering investing in a new technology. Okay. Taken in isolation, this investment may have a negative net present value. So it does not appear to be worth pursuing. So it is an R&D project, whether we can do R&D or not. Maybe R&D is negative. maybe developing a technology with negative NPV project, right? Hiring scientists and buying capital to do research is maybe too expensive. But maybe it has included real option. However, it may be the case that investing in this new R&D technology affords the company the option to develop more advanced and profitable technology at a later date. So by investing R&D right now, invest R&D, maybe you have an option to invest in future for more technology. So by investing R&D today, you are basically creating an option. Okay? So as a result, the investor might ultimately be positive NPV value project that is indeed worth pursuing. So these types of investment opportunities are often called real option, and economic and financial engineering provide a useful guide toward valuing these instruments. Okay? The real option example that we consider here is the Simplico gold mine example from David Weinberg, Investment Science. So again, this example is a summary of the case in the book. Okay? The goal is to value risk on a gold mine and value option to increase the rate at which gold can be extracted from a technology. Okay, so first, there is a gold mine, and we want to calculate if it is 10-year contract, what would be the value of leasing, of contract. And second one is like R&D project. Okay, R&D. There is new technology and whether to buy the technology or not. Okay. First one is description of the case. The Simplico gold mine. Gold can be extracted from Simplico gold mine at a rate of 10,000 ounces per year at a cost of 200 per ounce. Okay, so per ounce it costs $200. So intuitively, if gold price is less than $200, then I will not drill. Yeah, so 10,000 ounces per year. Okay, so let's say it is fixed. The current market price of the gold is $400, and it fluctuates randomly in such a way that it increases each year by a factor of 1.2 with probability 0.75, or it decreases by a factor 0.9 with probability probably 25%, i.e. gold price fluctuations are described as binomial tree with each period corresponding 1 year. Okay? But then, we know these are very important information. Movement by up 1.2 and then movement by down 0.9. We know they are very important information. But 학생들 복도에서 좀 떠들지 말라 그래. 얘 수업하다 보면 이런 경우가 왜 이렇게 양식이 없니, 학생들이. 나 이런 경우 너무 많이 봤거든. 야, 뻔하게 수업하고 있는 줄 알면서도 이렇게 복도 지나가면서 떠들고 말이야. 이 보면 교수님들 연구실 앞에서도 막 뭐라 누군지 모르겠는데 이제 나름대로 자기는 나와서 전화통화 나와서 한다고, 강의실에 나와서 한다고 해놓고 나와서 교수님들 연구실 앞에 가서 큰 소리로 떠들면서 핸드폰 통화하더라고. 아 정말 내가 나가서 뭐라고 하기도 그렇고 좀 창피하잖아. 그렇지. 다 아는 이 대학생들인데 그래갖고 야 핸드폰 뭐 이렇게 알아서 좀 하면 안 되나. 그렇습니다. 어디까지 했지? So we know they are the very important information, size of going up or size of going down. But we know it is unimportant. The probability, objective probability, 75% going up and 25% going down. We know they are not important at all. Right? In the valuation, they are not important. Intuitively, it is important, but in fact, okay, apparently it is important, but in fact, when we do binomial pricing or more generally is derivative pricing, they are actually not important, irrelevant. So anyway, it is really relevant. So we will see this one in detail. And then another important information, risk-free rate is 10%. We want to compute the price of risk on a gold mine that expires in 10 years. Okay, so leasing is 10 years, leasing for 10 years. It is assumed that any gold that is exchanged in a given year sold at the end of the paper at the price that prevailed at the beginning of the paper. So it is in substance a weird assumption, right? I mean, it is a simplified assumption because in this example, it costs like, it takes like 1 year to produce something. In the beginning of the year, we decide whether to drill or not. We decide the drilling in the beginning of the year, then we can get the gold at the end of the year. But in the beginning of the year, we observe gold price and we make a decision, right? And then at the end of the year, when we finish the drilling and when you got the gold, that gold price may be different from the price at the beginning of the year, okay? Right? But in this case, to make it simple, problem simple, let's say gold price is same. This is maybe unrealistic assumption for you, but it can be realistic because when we decide the drilling, maybe we do the forward contract that we sell gold at the end of the year, right? So it is maybe sound unrealistic, but it is not that unrealistic, okay? Because we can use the forward contract. So possibly we can observe the forward price that matures 1 year, okay? So based on the forward contract, we decide the drilling or not, and then we use that forward contract to sell the gold we drilled. Anyway, to simplify problem that gold price is same for 1 year. And the next year, so beginning of the end of the gold price, another one. Something like this. And the gold price binomial let is given below. Okay, so we can write down this one. Okay, so actually, this is the example I created. So extraction rate, 10,000 ounces per year. Gold extraction rate. And extraction cost is $200 USD per ounce. And current gold price is $400 US. Okay? And upside 1.2. So let's define name range. This one as up. Okay, let's say downside, this one is down. DN down. And then this is probability going up, probability going down, which is actually unimportant. And then gross interest rate is 1.1, right? Important rate is 10%, so gross interest rate is 1.1. Okay, 10%. So if we put $1 at the end of the year, it becomes $1.1. And the risk neutral probability, which is dependent Q, which is, as you know, risk neutral probability is basically RF minus, RF minus DN divided by up minus DN, right? This is risk neutral probability that we learned, right? So actually, this is the important part. This objective property is not unimportant, and this is what matters. Let's make it important. And then, yeah, so, and then in this case, okay, this one is, okay. Let's skip this one. And then by using this information, we can use gold price lattice. So current gold price is 400. Current gold price of 400. Okay. Then gold price is, then if it goes down, this one multiplied by DN. Right? And then DN, 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 DN. If we keep going down, it looks like this. Okay? And then for going up part, then our usual trick is we use this one. This one multiplied by up divided by DN. Okay? That is our usual trick, right? Because then it is same to going up, right? Going down, so it is going up. So from here to here, we have to get rid of effect of down, and then we multiply up. So up divided by DN. And then done. Okay. So it's a fluctuation of gold price, and sometimes gold price is like more than $200, and in this case, gold price less than $200. So we can draw gold price rates. Okay, and then let me check whether the number is the same. 2476, 2476.7, 139. Okay, they are same. Okay, same. So it is our fluctuation of gold price lattice. And then next, let's read the next part. The risk neutral probability are found to be 2/3, and which is going up 2/3 and going down 1/3, which is again risk-free rate minus movement of down over up minus down. Okay. Now the value of risk is then computed by working backwards in the lattice below, because the risk expires worthless at the nose value at 10 t equals 10, then or 0. Okay. So in order to calculate risk value, so I mean our question is okay, as the owner of the maybe the owner of this oil field, not gold mine, I will lease this one for another person for 10 years. Then question is how much money I have to receive right now for the rest of 10 years. Okay. So that is our question. And then if one has a gold mine, then at the end of the year, 10 year, okay, 10th year, because it expires at year 10. So at year 10, the value is 0. Right? Value is 0, right? And then, but year 9, we can extract the gold, right? Extract the gold. Then you can calculate the gold price. You can calculate the risk value at this particular period. At this particular period is then, it is very simple. Okay. First, is everything in million. First, okay, so let's define this quantity. How much quantity extract per year? Quantity. So first and then C2 extraction. Let's define this one as the cost as well. Quantity, and then this is cost. And then, okay, so let's assume that we are here. Right, delete this one. Okay, let's assume that we are here. Okay, we are here. Then we have to decide whether we drill or not. Okay, clearly gold price is very high and extraction cost is just $200. So we should drill, right? Right? So basically, what we have to do is we have to do max. Okay, we have to do max. Okay, this one minus cost and 0. Okay, so if we decide to drill, then because we invest just $200 for drilling ponds, but ponds it is that high, okay, that expensive. So we make this kind of money, right? This kind of money if it is so we drill. But thing is that if we drill, we can extract 10,000 ounce. So we have to multiply quantity. So this is money actually we make, right? But then in our assumption, if we decide drilling at the beginning of the year, then we actually have a gold at the end of the year. So we have to discount it back, right? So we have to discount it. RF, right? So it is the present value now. Present value, and then this number is basically too big, right? And then want to change everything in millions. Okay, so we are at this particular point. The value of this mine, okay, value of this mine is 16.9 million US dollar. I mean, it's simple, right? Any question? Felix, any question? No, right?
No.
It's pretty simple, right? Straightforward. We combine gold price, extraction cost, produce gold, and multiply quantity and discount it back because it's end of the year. Okay, so we do the same. Okay, clearly this one is straightforward, right? The price of gold is just $155, so we don't bother to drill because price of extraction cost is $155, right? So we don't want to do that. Okay, so the answer is same. And then now let's assume that we are here. We are here. Then we should do the basically same thing. Okay. Okay, we decide, again, we decide whether to drill or not, okay, and price, compare the price of the gold and extraction cost, and then divide it by multiply quantity. So, but thing is that now there is another option, where this is the value of the gold at the particular year, but it's leasing contract, so next year we can also operate the mine as well, right? At the rest year. So, at the particular point, our value is okay. This year we can extract this $13.8 million amount of gold, but the next year we are either here or here. So next year is also valuable, right? So we have to take on top of this value as well, right? So plus, what we have to do is with probability of Q, with probability Q. What I can do is offset. Let me use offset. And then this one is I-21. Okay, I-21. And then first minus 1, multiplied by Q. Multiplied by Q. And plus offset I-21. And then 0, 1, and multiplied 1 minus Q. Okay? And then we discount it because it happened in the next year. We discount it. Let me check whether our answer is the same. Okay. So, I mean, you all know what I mean by offset, right? Did I explain what I mean by offset? Oh, I didn't. So this part is, again, this part is this one. Offset I-21, I-21 minus 1 is this one. And offset this one is. So what I mean by, first this part is the value of the gold mine this year. And this is continuation value. Continuation value is I can either this one with probability, risk neutral probability Q. And I, which is this one with risk neutral probability 1 minus Q. Right? So I take the average expected value and discount it. And then here offset means, okay. Okay, so in this case, let's say offset .0 is this one, okay? Yeah, 0.0 this one. And then when I want to reference, so, right? So because offset, when I say the 0, 0, it is base. It is exactly the C23rd. But when I want to actually reference this one is from the perspective of this one. It is 1 column away, 1 column to the right, and 0 column to the above or below. Okay, so this one is again. Okay, this one is same to C23rd, but because it is 0 column, 0 row, neither up or down, so it is 0. But it's 1 column to the right, so 1, so 6. If I want to reference this one, C23 is again this one, so it is the one column to the right, and now we have to going one column up, one level down. So it is minus 1. It is 3. And what it should be this one? It should I go one column right and one column down. Okay? So this was very convenient. Yeah, I recently learned. And then another, this one is right. So it is a 0 column. Neither right or left is 0, but it is, I go one level down. So this one. And this is minus 1. Right? And then this is right. This is, I can go 1 minus 1, and I go minus 1. Okay? And then this is the 0, same log, and it is 1, so minus 1. And this is the minus, this is 1 and minus 1. Right? So I express those numbers in terms of this one, relative to. Okay. So it is simple. Okay. So I thought offset is more useful than just referencing. Okay. So that's why, from this perspective, okay, here I-21 is this one. So from perspective I-20 was this one itself, and from the perspective of 1 right and going up multiplied by Q, and 1 right and same row, 0 and 1 minus Q, and divided. So the first part, this one is important. It has two parts. The first part is the value of the gold this year, and second part is continuation value. Value of the gold mine by keeping the gold mine. Value of the lease by keeping the gold mine for the next 1 year. Okay? Because next 2 years end. Okay? And then at this point again saying I have to calculate the value of, so at this point again it is saying I have to calculate the value of the gold for this year, and then continuation value. Continuation value is again this one and this one. Either this one and this one. So this one multiplied by Q, this one multiplied by 1 minus Q, and discount it. But since I already linked it, I can simply copy and paste. $24.1. Okay, 24.1, exactly the same, right? So if I lease this gold mine for the next 10 years to someone, I have to receive $24 million. Okay, so let's read it. The risk found to be a Q 2/3 and 1 minus 1/3. The value of the risk is then computed by working backwards in the relative below. Because the risk expires worthless, the node values at t equals 10 are all 0. The value 16.9 on the uppermost node at t9, which is this one. For example, it's obtained, so this one is obtained by discounting the profit on at time t equals 10 back to the beginning of the year. We therefore obtain 16.29 multiplied by the value of this one. Okay, value of this one. Okay, value of this one minus 200. So it is the value of the gold, which we can sell at the end of the year, and it's the extraction cost. And then we have to multiply. It generates 10,000 ounces per year. So multiply quantity and discount it by 1.10%. Obtain 16.94. The value at a node in any earlier period obtained by discounted value list, and then the profit obtained at the end of the year back to the beginning of the year, and adding the two quantities together. Okay. So the first part is the extraction value. Second part is the continuation value of the option. For example, in year 6 of the central load. Okay. For example, where is it? Okay, this one. 6 node, okay, this one. Okay, this one. So in the year 6 central has a value of 16.6 watt. I think 60.0, okay? Because this one is this one. This is obtained by, okay, at this particular period, the price of gold is this one, so extract minus extraction cost, and I produce 10,000 ounce and I discount it. So it is extraction value now. And continuation value is because we are here, next year we are either here or here. We are here with probability Q, risk neutral probability Q, and we are here with risk neutral 1 minus Q. So I calculated expected value of this one and this one, and discounted 1.1, and then move on that. It is $12 million. Note that in any year when the price of gold is than 200, it is optimal to extract no goals, and so no profits are recorded for that year. We find the value of the risk at time t equals 0 is $24.1 million. So, that is that. Any question? 질문 있어요? Any question? Now, suppose now we have a new technology. Suppose now that given this new technology, suppose now that it is now possible to enhance the extraction rate to 12.500 ounces per year. Okay, so in this period we can extract gold more. Okay, in the previous cases it is just 10,000. Now we can extract 12.5 thousand ounces per year. So you can extract more by purchasing new equipment, and the cost of equipment, cost of new technology is 4 million. 김일영 학생 졸린가 봐. 졸리면 일어서서 들어도 돼요. $4 million. And then once the new equipment is in place, then it remains in place for the future years. So once I install the technology, it goes forever. Okay. Moreover, now the extraction cost would also increase. So it can produce more, but it is also more expensive to produce per ounce. So it is $240 per year with new enhancement in place, and at the end of the list, the new equipment. The important part, once I install new equipment, becomes a property of original. So I install new technology here, and there is no liquidation value. I can resell the technology. So it is simplified assumption. So if there is option to resell the technology, it is simple. At the year 10, I can add the liquidation value, right? So it doesn't matter. But anyway, so the owner now, the owner of the list therefore has an option to install the new technology anytime, and we wish to determine the value of this option. Okay? So basically, the owner of the lessee of the gold mine doesn't have to use the technology right away. Okay? They just wait, and if gold is expensive enough, then they use new technology. They invest and they use new technology. Okay? Anyway, so we want to calculate that kind of option. To do this, value of the risk, assuming that. So to do this, we first assume the value of the risk, assuming that the new technology is in place at t0. So let's assume the value of the gold mine, assuming that we have a new technology from the beginning. Okay, this is done in exactly the same manner as before. The value at each node and period are given in the lattice below. Okay, so new extraction rate, and then this is, let's say, in quantity. Let's say quantity new quantity. And then price of equipment is the, I think this is the, okay, this is already investment. And new extraction cost, let's say this is the cost new. And the other thing is exactly the same. So, let me hide this one for the time being. Hide it for the time being. So on the new technology, again, at the end of the year, at the end of the 10 year, because the contract expires, it is all zero. All zero. or 0. And at year 9, okay, at year 9 again we do the same thing. Okay, we do the max, this one, minus cost new and 0. Okay, and then because given the new technology, I can earn quantity new. Okay, quantity new, and then I have to discount it back. Okay, so it is the value of the at a particular point, and I want to make it everything in millions. So okay, this so it's year 9. Okay, this one. And then year 8, now I have to take into account the continuation value. So again, first, this part is the same. Okay, same. And then plus. Okay, continuation value is, we are here. Okay. Offset. And then we are offset. We are at, where are we? We are at the I 3, and then 0 minus 1 multiplied by Q plus offset I 3, and then same line, so it is going down 1 multiplied by 1 minus Q. And then I have to discount it back RF. Let me see whether I have a right. Okay, right. And then paste. 왜 페이스가 안 되는 거야? 거의 이상하고. Okay, so the price of the gold mine is now, with the new technology, $27 million on high. Okay, $27 million. Clearly, it is more valuable. But thing is that without the technology, cost of the mine is 24 million. And with technology, it is 27 million. But value of investment cost of technology is $4 million, right? So it is at the current, at time 0, in a naive way, it is negative NPV project, right? Right? It's negative NPV project. I can increase the value of gold mine less than $3 million, but cost of the new technology is $4 million. So it is negative NPV project. So we can think that this technology is not valuable. We may believe so, but thing is not that simple, because although at time 0, it is unwise to use that technology. Maybe at some times in future, maybe it is optimal to exercise the technology, right? So if we take into account the value of the technology, because we don't have to exercise the technology right now. We can just hold it and wait, and then we can use the technology at the time only when it is advantageous, right? So we have to think of that kind of option value, and the question is, if we take into account that option value, whether it is valuable to have that technology or not. Do you know what I'm saying? So that's the key question. Okay. So currently it's a negative NPV project, but because we don't have to explain the if we don't have to exercise the technology right now, we simply exercise technology when it is good for us in future. Okay, so if we include that kind of option value, then maybe the value of the gold mine can go up. Then it is maybe the technology can be positive NPV project. So we want to take into account that. Then how to do that? The answer is actually at the next one. I don't think we have the time for this one. But anyway, to give you the answer, the value of gold mine raised with equipment option in $1 million. If we have that option, then value is $24.63. Okay, so it is actually currently more valuable to hold that option, equipment option. So for this one, okay, since we don't have enough time right now, okay, so let's investigate this one at the next, okay, this Friday, maybe the next class. Okay, and thank you and see you this Friday.